So we know a few ways to solve a system of equations or a linear system. Making a table is one thing we've done, and just so you know, that's usually a pretty inefficient way to go because you tend to have to get a lot in there, and a lot of times the actual ordered pair, the solution won't necessarily show up, and you'll have to kind of guess and check. We have used graphing, and I'm going to show you graphing and where maybe that would be advantageous. And then substitution, which is going to be beneficial every time that we have a coefficient of 1. So I've made up 6 systems of equations or linear systems to investigate. The top one, we already know what x is. Since x equals -3, we can simply replace the x in the second equation with that and solve for y. So y equals -2 times -3 plus 1. So y then would equal 6 plus 1. So the y value is 7. And we already know the x value. It's -3. So my solution is -3, 7. Now I want to show you on the graph how we could come up with that solution as well. So x equals -3 is a vertical line where x is -3. 1, 2, 3. And you would want to use a straight edge if you could, rather than freehanding it. And then this equation, y equals -2x plus 1. Well, we know the slope is -2, and the starting location is +1 on the y-axis. So here's +1, and then we go down 2 and right 1, down 2 and right 1, down 2 and right 1. And also, well, I'm looking for the point of intersection, so let's go up 2 and left 1, right? With a slope of -2, well, that's either -2/1, which means down 2 and right 1, or I can switch the location of that negative, so 2 over -1, which means up 2 and left 1. So 1, up 2 and left 1, up 2 and left 1. And look at that ordered pair right there. That is -3 and up 1, 2, 3, 4, 5, 6, 7. So we can see that it is, we can see what that solution is. And I'm going to keep using this space for my other ones, and so I'm going to need to erase it. This red one, let's go ahead and graph it first and then use substitution, because we can see that y equals 2. We can easily substitute that in place of 4. I mean, you can almost do the mental math and get the ordered pair right now. But y equals 2 means that we go up to where 2 equals, well, 2 on the y-axis and draw that line. And then the other one, we're going to have to isolate y. So I add 6 to both sides to come up with x plus 6 equals 4y. And then divide both sides by 4 to isolate y. So this becomes 1/4 x plus, if I simplify, 3/2 or 1.5 equals y, which means that my y-intercept is 0, 1.5, and the slope is 1/4. Also, -1 over -4, in case we ever needed that, which of course would be down 1 and left 4. But we're going to be using the regular one, 1/4, up 1 and right 4, after we locate 1.5. There we go. So 1.5, then we go up 1 and right 1, 2, 3, 4. So if we were to connect those 2 points, and we could do more, up 1 and right 1, 2, 3, 4, down 1 and left 1, 2, 3, 4. Of course, I'm freehanding it. It looks like it's right about at the order pair 2, 2. Well, let's go ahead and use our substitution and verify that. So we simply replace the y in the top equation. X equals 4 times 2 minus 6. So x equals 8 minus 6. So the x value is 2. And we already knew that the y value is 2. So the ordered pair, 2, 2. Somehow I lost my other solution up there. All right, so those two were relatively simple. And you can see that substitution was actually faster than graphing there. Well, let's look at the white one. Now, the y equation is set up for us to graph because y is isolated already, which means that we can quickly and easily see the y-intercept and the slope. So for the top equation, the y-intercept, let's use a different color here. Let's use the color that it goes with. So the y-intercept is 0, 5, and the slope is -1. And we always want to put that in fraction form to remind us to go up 1 or down 1 in this case, and right 1. And on the bottom, the y-intercept is -7, and the slope is 2, meaning 2 over 1, also the same as -2 over -1. I don't know if this white's going to show up on the graph. Let's take a look here. So 0, 1, 2, 3, 4, 5. Oh yeah, you can kind of see it. So down 1, right 1, down 1, right 1, and we can see it's going to keep going in that direction. The other one, -7, -1, 2, 3, 4, 5, 6. Well, that's right, good. And then up 2 and right 1, up 2 and right 1, up 2 and right 1, up 2 and right 1. Well, how about that? There it is right there. I don't even have to draw the lines, and I was able to count out that slope. Let's go ahead and verify that with some substitution. Since y is isolated in each one, we simply, we could, however you want to think about it, either replace this y with 2x minus 7, or replace this y with -x plus 5. It doesn't really matter. So let's go with, there it is. Let's just write it as -x plus 5 equals 2x minus 7. And now we need to isolate the x's. So I'm going to subtract 2x from both sides. So now I have -3x. And of course it's gone on this side. Equals, and I need to get the 5 to the other side, so subtract 5 from both sides, which of course gets rid of it on the left, and that equals -12. Divide both sides by -3. And the x coordinate is positive. A negative divided by a negative is a positive 4. And now I plug that back into either one. And probably both is a good way to check, but the easier one is the top one. So I'm going to show y equals -4 plus 5. Well, -4 plus 5 equals 1. So my solution is right 4 and up 1, which is what I saw on the graph a moment ago. So I write it as an ordered pair, 4, 1, and then check it in the other equation. 2 times 4 is 8, and 8 minus 7, that is the y value of 1. All right, so now let's look at the green one. If we're going to graph this one, it's going to take a little bit of work to isolate y in both. The top one is not too difficult. I subtract x from both sides, and I get y equals -x plus 8, which tells me that the slope is -1 and that the y-intercept is 0, 8. So 1, 2, 3, 4, 5, 6, 7, 8. And then down 1 and right 1. And of course, that's that -1 slope. Keeps going. The bottom one, I need to start by adding 3x to both sides. So 2y equals 3x plus 1, and then divide both sides by 2. So y equals 3/2 x, that's my slope, plus 1/2, that's my y-intercept. Equals 0, 1/2. So starting at the half right here, I need to go up 1, 2, 3, and right 1, 2. Up 1, 2, 3, and right 1, 2. So it looks like it's going to be that ordered pair right there. But let's use substitution. Now I am going to keep the y equals -x plus 8. I might as well, because I just needed to either isolate x or y, and it doesn't matter. So I'm going to keep that and replace the y in the second equation. And I also want to talk about when we use substitution. In all of these, I hope that you notice that there's always a coefficient of 1. It's either already, look up in the blue one, x is already isolated here, y is already isolated here. Both y's are already isolated. In this one, neither one is isolated, but it took us one step to isolate either x or y. If we look at the yellow, you know, all 4 of these, well, 3 of them don't have x coefficients of 1. The bottom x does, and so we're going to isolate that one. And then the blue one, none of them do. So graphing, you almost never want to solve a system by graphing unless it actually ends up on an ordered pair, the vertical and horizontal. It's not going to be real convenient. It's going to be hard to guess at what fraction or decimal that is. So the strategy is to not use graphing. Graphing gives you an idea or an estimate, and then if you feel like you do have it, check it in both equations. Check that x and y coordinate in each equation. But if you have a coefficient of 1 on either the x or the y, that's when you want to isolate one of those and use substitution. There's another method of solving linear systems, and it's called by combination or elimination. And that's the way that really we probably would use for this blue one. And I just want to show you how challenging this blue one is in just a minute. But I'm going to write that up on the screen, what I just said. So there you go. That's the main idea. Graphing gives you an estimate of the solution. You must check it in both equations. Use substitution when one of the coefficients is 1. Isolate that variable. So let me continue on with the green one. Negative 3x plus 2 times in parentheses negative x plus 8 equals 1. Now we're going to distribute. So negative 2x plus 16. So we're going to combine like terms, and we're also going to subtract 16 from both sides. So negative 5x equals negative 15. Obviously dividing by negative 5 on both sides, x equals 3. So we have the x coordinate, and then we plug that back in to x. So y would equal negative 3 plus 8, which equals 5. So the y value is 5. So the coordinate, or the ordered pair, is 3, 5. And of course we can see that 3 plus 5 equals 8. Negative 3 times 3 is negative 9. 2 times 5 is 10. Negative 9 plus 10 equals 1. So we just checked it. In the yellow one, we've already talked about how a coefficient of 4, 6, 5, we don't really want to have to mess with subtracting something from both sides and dividing by that thing. We're going to end up with a fraction here. Whether we isolate the y, we would divide everything by 6, or isolate the x, we would have to divide everything by 4. If I isolated the y in the second equation, I have to divide everything by 5, and I'd end up with a 1/5 x. It just makes sense to isolate this x. So we're going to subtract 5y from both sides. So x equals negative 5y minus 10. And then I'm going to substitute that in for the x in the first equation. So 4 times negative 5y minus 10 minus 6y equals 12. So that's negative 20y minus 40. I'm going to add 40 to both sides and add my two negative 20y and negative 26y to get negative 6 to get negative 26y. That's what I'm trying to say. Equals 52. And aren't we glad to see a multiple? I'm out of space down here, but I do want to divide both of the sides by negative 26. I can't write it there, but y equals negative 2. Now I plug that back in to the y. So x equals negative 5 times negative 2 minus 10. Yes, that equals 10 minus 10, or 0. So we see that the solution for this one is 0, negative 2. And if you were to graph it, you would see that. Now this light blue one, or this blue one right here, none of these are convenient. I'm going to have to subtract 3y from both sides and divide by -2, or add 2x to both sides and divide by 3, divide both sides, everything by 5 after I add 4y, or subtract 5x and divide by -4. None of these are convenient. Of these, if I have to use substitution, I would isolate this x, because dealing with halves for me is easier than dealing with thirds, fourths, or fifths. So I would isolate the x. So that would be -2x equals -3y plus 13, and divide everything by -2. X equals positive, because when I divide each of these by -2, I get x equals 3/2 y plus negative, or let's just go with minus 6.5, and I want that, well, maybe I want to leave it 13/2, because now I'm going to have to replace this x, since I took this first equation down, and I need more room. So 5 times 3/2 y minus, I'm going to use 13/2 minus 4y equals 7. So this is 15/2 y minus 65/2 minus 4y equals 7. 65/2 is 32.5, so I'm going to add 32.5 to both sides. And then I'm going to add together the 15/2 and the -4y. Well, 15/2 is 7.5. So 3.5y equals 39.5. Well, now to divide both sides by 3.5, we really need to multiply by the reciprocal. So turning it into an improper fraction, 2 times 3 is 6 plus 1 is 7/2. So I need to multiply both sides by 2/7. And really the whole point of this is to show you why we don't always want to have to do substitution, and why there is that other method that you will learn later. And using my calculator, that comes out to be 11 2/7. Another reason why you don't want to have to figure out that y coordinate. So that is just the y coordinate. So whatever the x coordinate is, and then the y coordinate is 11 2/7. And now I would substitute that back in place of the y right here. So 11 2/7 times 3/2 is 16 13/14. And when I subtract 6.5 from that, I get an x coordinate of 10 3/7. So again, you would not want to try to find this solution by graphing. And even by substitution, it was difficult, and that's why I said that there's that other way. So the strategy, of course, is right here.